Hi everyone. In this video, we look at the first order ray tracing using the ABCD matrix method for a doublet lens. So in the previous video, we looked at the YU tabular method for tracing the ray of height 0 and angle 0.01 through the system. And we used these two equations, right? Like one is the refractive equation and one is the transfer equation. And now what if we decide to change the ray height or the angle? Then we just need to do all the calculation once again, right? And it's like very inefficient. Just by changing this height or angle, we have to do the entire calculation. So there has to be some other better way of doing, and that's why we have this ABCD matrix. So we have these two equations. We are just simply writing them in terms of matrix notation. So yk plus 1 is equal to yk plus the exiting angle plus the distance, right? D dash k, that's all. And uk plus 1 is simply equal to u dash k, which is the exiting angle. And similarly, I have written it for here. You could just do simple multiplication and then verify what I have written here. It's like very straightforward. So now let's go through the previous example which we have shown in the previous video, like so in terms of ABCD, so that it becomes more clear. So for the surface T0, so we just have to substitute D0 dash, which is nothing but 300, which is this distance. So it means that this is this transfer operation. So 300 we just put here. And R1 is the refractive index here. So n dash k, it is the refractive index after the surface, which is like 1.5. So we just put 1.5, and nk is the refractive index before the surface, which is like 1 put, and the focal length is like on the power of the surface is 0.01, and we put 0.01. So we just substitute all these values here. And similarly T1, so all the T's are easy. So for T1 is 10. So for example, T0 is 300 and T1 is 10 and T2 is 200 and T3 will be X, which we need to find. So it's very simple, 10. And again for RK, I will explain this once more. So R2 is like this surface, and the refractive index after the surface is like 1.6. So we write like 1.6, 1.6, and before the surface is 1.5. So we write 1.5, and the power of system is like minus 0.02. So we have written minus of minus, so plus 0.002, and so this is R2. And we have defined T2, and similarly T3, you could try this for yourself. So this becomes 0 because the power is 0, and before the surface the refractive index is like 1.6, and after it is like this completely R, right? So it's like 1, so it's actually 1.6. And T3 is the X which we need to find. Now, if you just multiply all these matrices, we will get the conjugate matrices. And then if we try to get only the system matrix, which is defined by R1 to R3, which defines this optical system, it's called the system matrix, and the entire thing is called the conjugate matrix. So the only difference is here we have the object distance and the image distance, right? Like T3 and T0. You need not do this calculation manually. Here I have a simple MATLAB script. You could copy this from the slides and then run it and then verify yourself. So here we have defined all the transfer matrices and all the refractive matrices, and then we calculate the conjugate matrices. And then the initial ray is like 0 height and 0.01, and then the final ray is simply the propagation of the initial ray through the conjugate, right? And then once you get the final ray, we set the height of the final ray is equal to 0, and then we solve for the x, and then we just print out the solution. It's what we got in the previous video, which is like 199 mm. Yes, and then you could write the initial ray height, the final ray height and the final ray angle in terms of the initial height and angle like this. It's called, so that's why the coefficients are called the ABCD matrices. And like for example, if you look at if you set b as 0, then yk plus 1 by y will be equal to the magnification, the ratio of the height of the image to the object. So it's called m, and the ratio of the height of the image to the object angle will be called 1 by magnification, like angular magnification. and the C will be like it's a simple trigonometry exiting angle by the incident height of the ray, then it's like minus of the power, right? Like 1 by focal length, which is nothing but the power, right? And by setting this variables A, B, C, D, 0, we get 4 conditions like focusing condition or conjugate and a focal and objective plane and the imaging plane at the front and rear focus. So I was thinking how can I explain them in more detail and intuitive way. And I think the best way would be to go through some examples, and then we also didn't talk about the principal plane, P1 and P2. So that is also there. So I think probably we'll work out a couple of examples in the next coming videos, so that it becomes like more clearer to you. But if you want to learn more about this theory or something, you could watch this um, these last 3 videos in this Coursera course. He has did a nice job of explaining them. But yes, but I didn't want to repeat what he has already done. So so probably let's see you in the next video where I will explain more. We'll go through some of new kind of examples so that new concepts are clearer. Okay. And once again, like thank you for watching. And please feel free to leave your comments. Have a good day.